Hi everyone, this is Mrs. Taylor bringing you lesson 17. First, before we begin, I need to make sure that you all took the time to watch the videos. That's linked into your math folder today. If you have not watched those videos today or in the past, please watch them again to help you solve the problems that we're going to work on today. You will need your activity book. All right, now we are on our math lesson 17. Okay, so a learning target for today is going to be review regular polygons with Puzzle Penguin. So we just did that. Then you're going to solve real world problems using area, perimeter, and volume. And that's why I wanted you to review the videos. Okay, and watch the videos first. Look at the dimensions of a rectangular prism, and then find ways to deconstruct a composite figure. Let's do a quick review with Puzzled Penguin. Yesterday you were supposed to have sorted cards, and today I want to just review before we move on. So this is the card L, okay, the quadrilateral L in the cards, and Puzzle Penguin put this in the oval 4 regular polygon because all the sides are congruent. So is this correct? Why not? If you said no, you are correct. And the reason is the angles are not congruent, not the same, right? In order to be a regular polygon, all sides must be congruent and all angles must be congruent. So you will need your student activity book and a pencil, and please turn to page 393. Let's quick talk about aquariums. So, these two right here are your typical home aquariums that some people like to have. An aquarium could actually be just a fish, like a bowl with one fish, like a fish bowl. That's an aquarium, right? The one here, this one, is the Georgia Aquarium in downtown Atlanta, and it's supposed to be the biggest aquarium in the world. And as you can see, that big old shark up there, that has got to be a really big aquarium. We have a couple of big aquariums in our state, one at the zoo, one at the Como Zoo, actually, that's two, and one at the Mall of America, that aquarium down by the Mall of America, right? All right, so just talking about aquariums. All right, I'm going to start reading page 393. Please follow along. Math and aquariums. A goldfish bowl is a small aquarium. Other aquariums, like those found in museums, can be enormous and have computer-monitored and controlled life support systems. Many home aquariums are made of glass or acrylic and are shaped like a rectangular prisms. A sketch of Naomi's home aquarium is shown at the right. Okay, so you can see here her aquarium. So let's start with the first one. Which faces of Naomi's aquarium, the top and bottom, the sides, or the front and back, have the greatest perimeter? And remember, a perimeter is what is on the outside, the rim-like. So the question asks, which faces of Naomi's aquarium, the top and bottom, the sides, or the front and back, have the greatest perimeter? If you said the front and back, okay, would have the greatest perimeter, front and back. It's the largest, right? This is the front here, and then the back would be the opposite side of that. That has the greatest perimeter, okay? All right, let's use the formulas that we know how to find area of each face, okay? And remember, area is length times width, and they want to know top and bottom, okay? So top and bottom would be 30 times 15, which would give us 450 square inches. And remember, you need to label it square because it's 2 units. Now they want to do the left side, left and the right side. Remember, we're doing area. So area equals, one side of that would be length times width. So that would be 18 times 15, which gives us 270 square inches. Okay. Now we're going to do the front and back, okay, the front and back area. So that would be area again equals length times width, which would give us 18 times 30, which is our length, which is the big number of 540 square inches, okay? Now they're asking us for number 3, well, let's use green. 3, to find the volume. And you know that volume equals length times width times height. Okay? So the volume of the aquarium, so think of it like how much water can hold this in this tank. So the length is 30 times the width, which is 18, times the 15. I'm sorry. So length, height is the 18, and 15 is your width. That all multiplied together would equal 8,100 cubic inches. And think about why I am saying cubic, because it involved 3 dimensions: length, width, and height. And in area, only did 2, length and width. Okay? So let's add a few changes to our aquarium. So this page on 394, I'm going to read the story and then we'll do 2 problems together. So residents of saltwater aquariums often include colorful fish. Some saltwater aquariums also include living plants, rocks, and corals. So we're going to use the sketch again that to Naomi's aquarium in order to solve the problems. The first one says, number 4, suppose 3 inches of sand were placed in the bottom of the aquarium. Calculate the remaining volume of the aquarium. So we know right away volume. Oh, I'm going to change to black. Hang on. Volume equals length times width times height, right? So if we already have 3 inches of sand on there, on the bottom already, so remember 18 is our height, right? Well, we have to change, so look over here. Please look over here. So we have 18 minus 3 because the sand is 3 inches. That equals 15. So now that's my height. Now I'm going to multiply that by 30 times width, which is still 15, times the height, because the 3 inches of sand is already there. So that equals 6,750 cubic. Remember, because this is volume, inches, okay? So that is number 4. Okay. So we have the sand, and then we have to subtract the height of the sand, which was 3 inches, from the tank height, which gave us 15. Then we multiplied the length times width times the new height, which gave us 6,750 cubic inches. So now let's look at number 5. Naomi would like to attach rubber edging along the top edges and along the bottom edges of her aquarium. Use a formula to determine the minimum length of edging Naomi would need. So this is asking you to find the perimeter. Okay, so the perimeter would be all the way at the top, right? And remember, a perimeter, it's a tank, so we have 2. So this side is 15, so this means this is 15, this is 30, and this is 30. So you have 15 plus 15 plus 30 plus 30, which would equal 30, 30, 15, 15 is 30 plus 30, that's 90 so far. But we have the top and the bottom, so that's another 90, which then the total perimeter, now the total perimeter would be 90 plus 90, which would equal 180 inches. Okay, remember, this is only one side, so it's one dimension. So your answer would be 180 inches, or you can put it into 15 feet, okay? We're going to skip the rest of them so you can practice on your own. All right, let's look at this rectangular prism. I want to just let you know that this volume equals 36 cubic units. What are some dimensions that we could use to get to 36? Maybe 4, 3, and 3. Are there others? Maybe 9. And then this would have to be 2 and 2. What if we use 6 and 2 and 3? Anything that's multiplied length times width times height, and it all equals 36, that's what the dimensions could be. So it all comes in different sizes, right? As long as we know that volume equals length times width times height. And the reason that these numbers combinations work is because they're all factors of 36. All right, let's look at something else and talk about volume. And so looking at this building, we're looking at it from an aerial view, meaning you are above it and looking straight down. This is the top of a building, and it looks like this, right? This is the outline of the building. The question to you is, if all of the dimensions of the building were known, could subtraction be used to find its volume? How would I find the volume? Because if you notice right here, this piece is not there. It is not part of, right? So how would I use subtraction to find the volume of this roof? Remember, you have to find the entire volume, and the little empty space here volume, and then you subtract it, and you would get the volume of only this shape, what's in there. So yes, you can use subtraction. Okay, this is the end of guided practice. Go ahead and do your practice sheets.